Welcome back. We've explored your journey into full stack engineering, learned what the industry is really like, heard memorable stories from real projects, and followed you through a typical day as a startup founder. Now let's look ahead. Technology seems to evolve every year. New frameworks appear, artificial intelligence is advancing rapidly, cloud platforms continue to grow, and businesses are becoming more digital than ever before. What does the future of full stack engineering actually look like?
I think it's one of the most exciting times to become a software engineer. Every industry is becoming a technology industry. Healthcare relies on digital platforms. Banks build sophisticated online services. Retail companies operate global e commerce platforms. Educational institutions deliver learning through web applications. Governments are digitizing public services. Manufacturing companies use cloud based dashboards and analytics. Even small businesses now depend on websites and online applications. As software becomes central to every business, the demand for engineers who understand complete application development continues to grow.
Many people are asking the same question these days. Will artificial intelligence replace full stack engineers?
I don't believe so. AI is changing how software is built, but it's not replacing the need for engineers. Think of AI as an incredibly capable assistant. It can generate code, suggest improvements, help identify bugs, explain unfamiliar technologies, write documentation, even create simple applications. But AI doesn't fully understand a company's business goals. It doesn't sit with customers to understand their challenges. It doesn't make architectural trade offs based on budget, scalability, security, and long term maintenance. Those decisions still require engineering judgment. The engineers who learn how to work effectively with AI will become even more productive.
So instead of replacing developers, AI is becoming another tool in their toolkit.
Exactly. Years ago, developers worried that visual editors would replace programming. Later, people thought low code platforms would replace developers. Now, the discussion is about AI. In reality, every new tool changes how we work. But businesses still need engineers who understand systems, architecture, user needs, and problem solving. The tools evolve. The need for thoughtful engineering remains.
What technologies do you think will become increasingly important over the next 5 to 10 years?
Several areas are growing rapidly. Cloud native application development continues to expand because businesses want software that scales easily. Microservices are helping organizations build large systems more efficiently. Serverless computing allows developers to focus more on business logic and less on infrastructure management. DevOps practices are becoming standard because companies want faster and more reliable deployments. Cybersecurity is becoming everyone's responsibility rather than the responsibility of one specialized team. Artificial intelligence is increasingly integrated into everyday applications. And API first development is making it easier for different software systems to communicate with each other. Understanding these trends will help engineers build applications that are ready for the future.
You mentioned APIs again. Why are they becoming even more important?
Modern applications rarely exist in isolation. Think about a travel booking website. It might communicate with airline systems, hotel providers, payment gateways, mapping services, weather platforms, and email notification services, all through APIs. Software today is like a connected ecosystem. Applications constantly exchange information. That's why understanding APIs isn't just useful, it's essential.
Many listeners are probably wondering what kinds of careers exist beyond becoming a software developer.
There are far more opportunities than people realize. Some engineers specialize in front end development, others focus on back end systems. Many become full stack engineers. Some move into cloud engineering, DevOps, cybersecurity, application architecture, technical consulting, engineering management, or product development. Others build software as a service, SaaS products. Some become technical founders, some choose freelancing. Some contribute to open source software while working remotely for international companies. The beauty of full stack engineering is that it opens many different career paths.
Let's talk about freelancing. Many beginners dream of working independently. How realistic is that?
Very realistic, but it requires preparation. Clients don't hire freelancers because they know a programming language. They hire people who can solve business problems. A strong portfolio matters much more than simply listing technologies on a resume. For example, imagine showing a client a task management application, an e-commerce website, a booking platform, a dashboard with analytics, a secure authentication system, a deployed cloud application. Those projects demonstrate your abilities much more effectively than simply saying, I know JavaScript. Real projects build credibility.
And what about startups? You've built one yourself. Is this still a good time to launch a software company?
I honestly think it's one of the best times. Today, a small team can build products that reach customers across the world. Cloud platforms reduce infrastructure costs. Open source software accelerates development. Online payment systems simplify global business. Artificial intelligence helps teams work more efficiently. You no longer need a massive company to create meaningful software. Many successful startups began with one simple idea that solved one real problem exceptionally well.
Where do those ideas usually come from?
Observation. Look for everyday frustrations. Maybe scheduling appointments is difficult. Maybe small businesses struggle with inventory. Maybe schools need better communication tools. Maybe healthcare providers need simpler record management. The best software ideas usually begin with someone asking, Kasu, why is this still so difficult? Technology becomes valuable when it removes friction from people's lives.
Many beginners feel overwhelmed because there are so many technologies to learn. How should they approach that?
Focus on building strong fundamentals first. Learn HTML, then CSS, then JavaScript. Understand how the front end works. Then learn back-end development. Understand databases. Build APIs. Learn authentication. Use Git. Deploy your applications. Understand the software development lifecycle. Cloud platforms and DevOps will make much more sense once you've built complete applications yourself. Trying to learn everything simultaneously often creates unnecessary stress. Progress happens one layer at a time.
Before we wrap up this segment, if you had to describe the future of full stack engineering in one sentence, what would you say?
I'd say this. The future belongs to engineers who can combine technical skills, business understanding, creativity, and artificial intelligence to build software that genuinely improves people's lives.
That's an inspiring thought. Today's discussion has shown us that full stack engineering isn't simply about websites or applications. It's about building the digital experiences that power modern businesses, create new opportunities, and shape the future of how people interact with technology. In our final segment, we'll ask one last question. If you could go back and advise yourself as a third-year engineering student, what would you do differently? We'll discuss the skills worth investing in, technologies to prioritize, beginner projects, freelancing advice, startup lessons, and one final message for everyone beginning their full-stack engineering journey. Stay with us for the final chapter of today's conversation.